Hello, everybody. Hola. How many of you are locals here? Like, majority from Spain? Everybody? No. So you traveled here for this conference and you came to my talk. That's, it's not depressing, but it's surprising. I'm always puzzled why people come to my talks. Do they want to learn something or do they want to entertain? I'm neither educative or entertaining. But anyways, how many of you know Kotlin and program something in Kotlin? The majority. Why did you come? It's for those who actually want to learn Kotlin. But anyways, you probably use Spring, right? It's the Spring conference. And so let's start. Well, my name is Anton. I work for JetBrains. I'm a developer advocate in Kotlin team. If you have been watching any of the release videos, that's me talking there. And I actually help some other teams like IntelliJ, TeamCity with the content that they built for the new features. And one of the latest products that we have in the line is Kodana. That's the static analysis and audit tool for your projects. So it can scan your project, find vulnerabilities, you know, something like that. I live in Tallinn. That's a picture of my city, and I actually have been involved in, like, professional background is from Java, so I've been programming in Java for about 20 years. So we talk about Spring and Kotlin today. In the context of extensions, we will get to those in a minute, but Spring is a Java framework. It's the most popular framework out there in the Java JVM ecosystem, but actually it's the most popular framework among Kotlin developers as well, although it's a Java framework. And the team has done a great job in extending the framework for Kotlin developers to improve the experience, you know, because in Kotlin you have this syntactical constructs and some features that you don't want to sacrifice when using Java libraries. And well, Spring developers want to make their framework more convenient to use for Kotlin developers as well. So this is not a talk where, like, it's a small disclaimer here. It's not a talk where I tell you everything, right? I give you pointers, and I hope you don't hate me for that, because I don't give you the internals. This is the most popular application on this conference, I'm pretty sure. Pretty much on every talk you can see that. And most likely you have used it, and well, you have seen that small radio button saying that you can use Kotlin with that. Have you tried it? Yeah, so when, like, half of the people have tried it. If you haven't tried it, you have to go back and try it. And yeah, so if you select Gradle option as a build system, you actually get a Kotlin flavor of the build file, right? And you can see some artifacts there immediately. This is like basically an automation for you because you just don't enable Kotlin there, but you also enable some compiler plugins. And if you have been using Kotlin with Spring, you probably know why they are there. Or maybe you haven't actually paid attention. Let's check. Who have tried this, generated Kotlin with Spring Framework project, and did not pay attention that there is a compiler plugin? Ignorance is the key. Well, it's fine. Okay, so let's take a look at the generated sample, like the most simplest application of Spring with Kotlin, right? We have the entry point there, and there you immediately actually see some Kotlin specifics. That run application function is not a Java function. It's an extension function that comes from the dependency for Kotlin. And if you look into the definition of it, you immediately see some weird things. If you're just a Java developer and you haven't seen any Kotlin code, there is like inline function and reified generics. Two features in one go. It's a little bit too much. Actually, on this single line, you can see 4 or 5 Kotlin features immediately, besides just inline function and reified generics. we get to those a little bit later. But anyways, the inline function, do you know what it is? Right, it's like C macro. It just gets substituted into the call side. Okay, we get that, and we follow like the simplest demo ever possible and create the controller. Just a slightly different syntaxes, but it still feels like we are programming normal Java application. You know, just slightly different. You know, we don't have semicolons, for instance, there. Like we write types on the right instead of on the left, and so on. But it's not really different. So we get further. We create services. We can use CRUD repositories, and we get to the data classes. That's probably one of the smallest features, like in Kotlin, if you think of it, but it has been actually very useful for many developers since it was added. One thing is, like here, it's a very naive one, right? We say we want to use data classes. That's a nice feature. It generates equals and hash codes by default and so on. And then what people usually do, they immediately think, oh, I can use data classes with JPA. No. This is like a nice syntactic sugar, but because of the defaults that the compiler generates, it's not designed to be used with JPA. In fact, if you go and read the documentation, the tutorials, whatever, actually you can find some of the tutorials saying, hey, I'm gonna use the data classes with JPA, and then just ignore whatever JPA features there are, like lazy loading and everything, and then they just sacrifice it. But that's wrong, right? You should use just normal classes that come from Kotlin, and don't rely on data classes with the JPA. But otherwise, if you are not using JPA, it's totally fine. You can get data classes and use it with other, let's say, implementations, other persistent standards, and be totally happy with it. So, just for the starters, we are just getting started here. You have to know that if you are getting started, you have to know that the classes are final. We have to use Spring compiler plugins or any other compiler plugins that adjust the classes for the framework. Then we don't use data classes with JPA. We use normal classes with JPA. And well, even if you are not starting a new project and just want to add Kotlin to the existing Java project with Spring, the start spring.io is a very good resource for that. Let's talk about extensions. So actually there is like a full page dedicated to Kotlin and Spring, and there is a special section about extensions where you can see a list of all the available extensions for the Spring framework. Have you ever checked that? Just a few people. Okay, that's the first pointer for everybody, right? It's not already a time wasted, so it was useful already. So that link for the current version of documentation is broken. You have to go to some older version of Spring documentation, and then it works. Yeah, I have to ping the Spring documentation team for this. Okay, and there you get the list of all the packages with all the extensions. Actually, it's not that many, and maybe for the application developers immediately it's not that useful, but I will show some of the immediately useful ones, and we'll dive in a little bit more into Kotlin as well. So, you know about extensions, right? If there is some type and you want to add some function, like here I have a string and I want a UUID representation of it, I can just create an extension function like this, say that it should return string, use the expression body syntax, and then in this scope where I have defined this function, it works. We can, how many of you know about extension functions? Perfect. I'm still puzzled. Why did you come here? Okay, so I don't have to explain this receiver in this context here. So we can just use all the nice features with type inference and extend for the extension as well. So if you look into the APIs they have in Spring, they have been there since forever, like as many years. JDBC template, I've been using it in 2000. I haven't been using it in 2004. It's like stable, right? And if you look how we can use it in Kotlin, this is the Java API, right? It's just 2 parameters. The query function is there like since forever. 2 parameters, role mapper, and a string, and we can use it like this. Nothing very interesting here. But let's take a look at this second function. That's the overload of the query function, where we have a prepared statement and role mapper, and on the last position we have the ID. So that's a var arc definition, right? So in Java we have var arcs on the very last position. But it would be much nicer. Imagine if this query wasn't just 1 line, but it was like many lines, and then the role mapper would be much longer, and then we have a very long disconnect between the query definition, the string itself, and the parameters in the list, like in the parameters list. So you have to somehow scroll maybe on your screen, or somehow visually match the arguments, which one goes where. And it would be nice to actually, switch the positions of the arguments between like the role mapper and the parameters list, but in Java we cannot do that. So here's just like a small feature, like some conversions. So instead of since it's a functional interface in Java, role mapper, there is just a single function. We can use those sum conversion features for the parameters. We just declare it as a lambda, and the compiler knows how to map this lambda into a type. So if we switch those 2 parameters like this, we get some interesting effects. So var arc is not at the last position anymore. It cannot be Java, right? And lambda expression is at the last position. In Kotlin we have this ability to move lambda out of the parameters list, so that it looks like a callback, but actually it's a parameter. So this function now is an extension function to the Spring JDBC operations class, and you just can use it like this. JDBC operations extension.kt. That's the extension that comes in that dependency for the Spring JDBC implementation. Cool. So you can tailor your framework or library with extensions, to make it more convenient to use for Kotlin developers if you are making some libraries in Java. Okay, so extensions and trailing lambdas, I already mentioned that, and probably since you all raised the hands, it's obvious for you and you have used it everywhere. But let's take a look at this example here. Like, we are using the same function, the extension function, and then we can create another function that takes some list of parameters, and on the first position I have the var arc, just to emphasize again that we can use var arcs in any position of the arguments in Kotlin. And then if we put lambda at the very last position, we can use the trailing and lambda feature for when we pass the parameters to make it more DSL-ish, or make it look more DSL-ish. So let's look into the ID for this example and expand on it a little bit. I hope you can see it well. Right, so this is the same code, but we have this extension on the top level, right? It's a public function on the top level, which is now possible to use in any part of your application, and that might not be good actually, because you need to help the users of your APIs to actually hint them, okay, in this context, in this file, you can use this extension, or now in this situation you can use this extension, and it's actually a good thing. The discoverability of the APIs is important usability topic. So in many cases, what is advisable to do is to scope it within some type still, like not on the top level, but depending on the use case, let's say. So if we create some object encoder, or let's call it context, and put it somewhere in the context, now we have two options. We either have to import this function, like explicitly, and that would be the obvious solution to this situation, right? But the other solution is to declare that now in this block we are working within some context, and we can say that the width block should take context, and now it will work. It's a very simple example, but it leads to an interesting ability for the library authors and for the framework authors to extend their APIs for Kotlin developers. How many of you have heard of context receivers? You're following the news, right? But majority is not. So you should go and subscribe to our YouTube channel, where we talked about context receivers and why they are useful and what cool features you can implement with them. This thing here is very basic context receiver in this situation, and we have control over the source code. But sometimes you don't have control over the source code. Imagine this function, or the context comes from some other library, and you cannot change that. You cannot say that, okay, in the context of this object that comes from a library, when I work with it, then string should get this UUID function. And with context receivers, it's possible. We can define different contexts and say, okay, if I have all of them combined, then Spring or any other of the domain classes that I have in the application could get an extension function. Anyways, that's not the part of my talk today, but that's another pointer for you. Okay, let's go further. So, more Kotlin extensions in Spring. I don't show that many of them today. It's just a JDBC template and another one. But I hope it will be useful for you just to know that they exist, and go and check the list because they are very simple. So we work with the controllers, and for instance, this model class that exists since, I don't know, since forever, again, since version 2.5.1. And if you work with this in Kotlin and you want to set parameters to the model, you need to do this. You need to convert it to a map and put this parameter into there. And the square bracket syntax is basically the operator overload of how do you say it? Operator overload function for the map. But it looks a little bit too much. It looks a little bit too noisy. And in Spring, you can find an operator, not in Spring, but in this is the version of the standard library function. It comes from Kotlin stdlib, but in Spring they have the operator overload for the model, so that you could use the square braces on the model type, which otherwise doesn't have this operator, right? So it looks like a map. So this leads us to the DSLs, and again, the entry point to the application, the main class. We know about the run application function, but maybe some of you don't know that you can actually have an overload of it, where you can pass a configuration block as a trailing lambda, where you can do whatever you want, like create new beans, create new configurations. And this refers to the Spring application, right? That's a hint. And how do you do that? Like, why is it even possible? And because this is the run application, and why do we have some strange type in the middle of the block? And if you look at the beans definition, then there you can have many different types as hints for those blocks openings. So let's look into the IDE for a second. We know about the, is it here? Right. So that's the example. If you go to the definition of the beans, you can see that there is like a bean definition DSL. And immediate question would be how many DSLs there are, because this seems to be a very specific one. And there's plenty. So if you search for it in the class path, you can have this many. I haven't counted, but it's a good number. So there are a lot of convenient things in Spring Framework for Kotlin developers. Excuse me, what is going on here? Right. Okay, and we can define a bean. We can do something else. We can define bean like this. Bean some bean. It doesn't exist yet. Create a class. Sorry. I prefer to do everything in one file. And or we can use this kind of syntaxes as well, like some bean. So it's like a replacement for the annotations, more explicit, and some people prefer that. Anyways, how is it even possible that we can declare different context types within the blocks? Let's look into a simple example here. DSL. Okay, so I hope it's visible. Imagine we have a function foo that takes a block of code. Like we want to execute some lambda within the function block. So that's a functional type, right? And well, it's easy, right? We can just execute this function, no problem. But and when we use it, we can just do foo like this. Cool, everything is good. Print alarm. But what if we want to execute this function or this logic within the block, within some context object, or within some context instance? Then we can say that the lambda is actually an extension to some type, let's say project. That doesn't exist yet, but we can create it. Oops. Okay, I didn't want to do that. Let me delete this one. Like this. And now the block should be executed within the context. We can do it in different ways. We can either provide an instance like this, because actually what happens with the extensions is that we get the type to which we are creating the extension on the first position in the list for the function, or we can say that, okay, we have an instance of that project and we can just apply this block of code within the instance. And then imagine if it's a factory, we can say that, okay, it should return a project instance, and we have a project instance here, and we just initialize it within this block. So this way we can actually create interesting construct DSLs and builders. And one thing that puzzles people a lot is that when we speak about DSLs in terms of Kotlin, they think that it's a separate language. No, it's not a separate language. It's just the idiomatic use of Kotlin syntax features. And even if you go to Kotlin documentation, you will not find a DSL, a word DSL in there. You can find type safe builders and functional literal with receiver. Those are two references that you need to know to use this feature. And combined with trailing lambdas or named arguments for the functions, you can actually create very nice DSL-ish constructs again for your application. And this is exactly what Spring developers do for. Sorry, this is here. This is exactly what Spring developers do with for Kotlin developers who want to use their framework more conveniently. So yeah, this is just the same example. Basically, you can have functions that receive functions. You can use trailing lambdas. You can use named arguments and extension functions and functional literals with receivers to achieve this kind of thing. We can go around null safety when we talk about Kotlin with Spring, because Kotlin is a Java framework, and Kotlin has this null safety feature. And well, if you're Kotlin developers, you know about null safety already. But I think as a community of Kotlin developers, we're still struggling with defining how to use it properly and what are the best practices. And I think we are getting there. I hope one day we can collect all those best practices in our documentation as well. And if, by the way, if you have any thoughts about it, you can come to me and share. But anyways, should I go over what null safety is in Kotlin? Everybody knows it, right? Everybody knows it. Yeah, so I just skip. Okay, we can return null. It can be null. Null safe dereferencing. I know what I'm doing. Anyways, so in context of Spring, because it's a Java framework, and we have to use the Java API, and Kotlin treats Java types as platform classes, where they are kind of nullable, but they can have a null value, but the compiler ignores it, right? For the practical reasons. Otherwise, your Kotlin code would be just polluted with null checks, because we are all using the Java frameworks and libraries. So the nullable annotations or nullability annotations that are actually defined with GSR 305, and those are meta annotations, and practically any framework can just implement their own by deriving from the GSR 305 annotations, like this. Like we have JetBrains annotations, for instance, but Spring has its own package as well, but they are all deriving from the same. And this is what helps Kotlin developers to use Java libraries a bit more conveniently or like safely. And what it creates for Kotlin developers who use Spring is that Spring annotated all their APIs, either with nullable or non-nullable type, and this helps using this APIs more conveniently. When you work with Kotlin, the compiler would immediately tell you that, hey, there might be a null pointer exception, you have to check it. Or some function does not accept a null value. Anyways, for this to work, you have to have this flag in your configuration file. And obviously, it's generated automatically. This is why people mostly ignore it. But it's there. You just have to know. So today, if you didn't know about some of the features of Kotlin, this is the list of the features I have somehow showed you in the slides. And type inference, inline functions, those like where the small ones when we use the run application function, and my favorite is the extension functions, because this is what actually lets you tailor the libraries and the frameworks more conveniently. Even if you don't use libraries, you decide I'm just building the applications with normal JDK, like with bare bones JDK, and you want to use JDBC, for instance. You can actually adjust with just a few extension functions. You can adjust the JDBC interfaces to look like it's a DSL in Kotlin. Okay, if you have any questions to me, I didn't have that many pointers for you, but I hope they were useful ones. And if you need the slides, they're there. I'm not a very modern person, I just prefer the URL. And if you have any questions to me directly, you can always reach out to Twitter handle. My DMs are open. So thank you for listening and have a nice day.